All right, so let's go over the homework. This is 3.5, day 1, page 146, numbers 1 through 10. All right, so let's take a look at number 1. So number 1, it says, use your grapher to support your analysis. We're finding dy dx. So I'll just copy down what it was. So number 1 is y equals 1 plus x minus the cosine of x. And we are just finding the derivative. So that would be y prime. Well, the derivative of a constant is 0. The derivative of x is 1 minus the derivative of cosine is a negative sine. Well, we have a double negative that's going to turn to a positive. So it's 1 plus sine x. That's it for number 1. Number 2, also finding a derivative of y equals 2 sine x minus tangent x. Okay. So first of all, we'll take the derivative of sine of x. Well, the derivative of sine is cosine, so we'll have 2 times cosine x minus the derivative of tangent is secant squared. So I can replace tangent with a secant squared. And there's really nothing left I can do, so I'm going to write this without the parentheses. So 2 cosine x minus secant squared of x. Number 3, y equals 1 over x plus 5 sine x. Okay, so before we take a derivative, let's rewrite this so that it has a negative exponent instead of that fraction there. Be x to the negative 1 power. And then when we do power rule, it'll be way easier. So now let's take the derivative. So that would be negative 1x. Then we have to subtract 1 from the exponent, so that would be to the negative 2 power. Plus 5 times the derivative of sine is cosine. Okay, and then let's just clean this up a little bit. We can drop it like it's hot. So y prime equals negative 1 over x squared plus 5 cosine x. And then that's it. That's the derivative. These are fun. I really like these. I hope you do too. Number 4, y equals secant, x secant x. So we have that x. X is a variable. So that variable in front means since I have a quantity times a quantity that I have to use product rule on it. So y prime equals the first times the derivative of the second. So the derivative of secant is secant x tangent x plus the derivative of the first would be a 1 times secant x. Okay, so altogether, y prime then is just x secant x tangent x plus secant x. Keep drawing on myself. All right, number 5. Y equals, oh, I wanted to use black. Sorry. I lost my mojo. Y equals 4 minus x squared sine x. Okay, so need to take a derivative. And the derivative of a constant, that 4, would be 0, so I'm not even going to worry about it. But I am going to need to use the product rule on this part of it. So the first times the derivative of the second, derivative of sine is cosine, plus the derivative of the first there, that would be a negative 2x times sine x. Okay, so y prime equals negative x squared cosine x minus 2x sine x. And that's it. That's all I can do for that one. Number 6 is y equals 3x plus x tangent x. Okay. So y prime equals, the derivative of 3x is 3, plus I'm going to have to use product rule on that one. So the first times the derivative of tangent of x, that would be secant squared x, plus the derivative of the first would just be a 1 times tangent x, squeezing it in there. So y prime equals 3 plus x secant squared x plus tangent x. Can't really do anything else, so that's the answer. Number 7 is y equals 4 over cosine x. Okay, so because of the fraction bar, that means that we're going to have to use quotient rule. Okay, quantity divided by a quantity. So y prime is going to equal low d high minus high d low over low squared. So the low is cosine x. The derivative of the high, the derivative of 4 would be 0, minus high is a 4 times derivative of the low. Derivative of cosine x is negative sine x all over low squared. So cosine squared x. All right, well, 0 times anything, wipe out. So y prime equals negative 4 times negative sine x would be a positive 4 sine x over cosine squared x. And this looks highly familiar. Sine over cosine we know is tangent, but that's a sine over cosine squared, so let's split it. Sine x over cosine x times 1 over cosine x. Because then we could take this and change it to tangent. So it's 4 tangent x. And the 1 over cosine x, that's the reciprocal of secant. So secant x. So 4 tangent x secant x is the derivative. How do we know when it's done? When there's nothing else that we could try to replace and make it smaller, okay, or nicer looking. Okay. All right, that was number 7. I think I can fit number 8 over there. Y equals x over 1 plus cosine x. Okay, so again, we have a quantity, so we're going to have to use the not quadratic formula, the quotient rule. Quadratic formula, oh my gosh, I must be really tired. Okay, so low d high minus high d low over low squared. So the low is 1 plus cosine x. The derivative of the high, derivative of x would be 1, minus high, derivative of the low, derivative of 1 is 0. Derivative of cosine x is negative sine x all over low squared. So 1 plus cosine x quantity squared. Okay. Well, when we multiply by 1, nothing's going to change there, so that's just a 1 plus cosine x. Negative x times negative sine x is a positive x sine x all over 1 plus cosine x quantity squared. And I tried to make that smaller and got stuck, so we'll just leave it like that. So I don't think we can make that any smaller. Alrighty, that was number 8. 2 more. Number 9. Is it the same type of problem? Yes, it is. Y equals cotangent of x over 1 plus cotangent of x. So I have a quantity divided by a quantity. So guess what? We're using the quotient rule again. So low d high minus high d low over low squared. So y prime equals low. Derivative of the high, well, derivative of cotangent is negative cosecant squared minus high. Derivative of the low, derivative of 1 is 0. Derivative of cotangent of x is a negative cosecant squared. All over low squared. Okay, well, let's go ahead and distribute that negative cosecant squared. So we'll get negative cosecant squared x minus cotangent x cosecant squared x. And the negative cotangent times negative cosecant squared is a positive cotangent x cosecant squared x. They're opposites. Opposites subtract. So these are going to cancel. Woohoo! So I have y prime equals negative cosecant squared x over 1 plus cotangent x quantity squared. And I can't make that any smaller, so that is it. Number 10. Where are you, number 10? Oh, same type of thing. Okay. So y equals cosine of x over 1 plus the sine of x. So I have a quantity divided by a quantity again, so that means I got to use the good old quotient rule. Okay, so low d high minus high d low over low squared. So the low is 1 plus sine x times the derivative of the high. Derivative of cosine is negative sine minus the high is cosine x times the derivative of the low. Derivative of 1 is 0. Derivative of sine of x is cosine x all over low squared. Okay, and we're going to need to distribute. So y prime equals negative sine x. Sine x times negative sine x is a negative sine squared x. Negative cosine x plus cosine x, negative cosine x times cosine x is negative cosine squared x all over 1 plus sine x quantity squared. Okay, nothing cancels, but we do know something here. Can I go to Chloe's house? Yes, go to Chloe's house, fine. So we know that sine squared plus cosine squared equals 1. And it's in here, but there's negatives instead. Well, we could factor out that negative. So negative sine x. Let's factor out a negative 1. So it'll make the sine squared x positive and the cosine squared x positive. And now we can replace sine squared plus cosine squared with what it equals. It equals a 1. And negative 1 times 1 is still a negative 1. Okay. And sine x minus 1 looks very similar to 1 plus sine of x. So I want to reorder that. So we'll put negative 1 minus sine x. Okay. It's so close. Let's try that factoring out the negative again. So make the 1 positive and the sign positive. And hey, look at that. I have the same quantities in the top and the bottom. I just have 2 quantities of 1 plus sine x in the denominator and 1 quantity 1 plus sine x in the numerator. So I could cancel this one out with one of these. So I'll have negative 1 over 1 plus sine x. So this one could go pretty far to simplify. The other ones didn't go that far. And that's 1 through 10.